Okay, so when you click on this link, you'll be able to use Express Setup and continue with the Express Setup option, and you can sign up for a serverless workspace. So you won't need a cloud account in order to have this workspace, or you can have your existing use your existing cloud account. Either way works. And for those of you who already do have a Databricks workspace, if you come over to the home page of your Databricks account, the main things that I want you to spin up now is first come to compute and create at least a 16.0 or higher machine learning Databricks runtime. So when you create a new compute cluster on the top right here, make sure this runtime is not 15.4 LTS, but at least 16.0 or higher, and machine learning is checked here. There are dependencies that we require and certain dependencies that we set up with those runtimes that will enable the demo to work. Next, you can come over to a lot of Zoom windows open. Come over to the workspace itself, over here on the left side, and actually use Git Folder here to get the code that we're going to use for today. And that will be, I don't have that handy yet.
I can share that in the chat.
Definitely. So for, again, those of you unfamiliar, we have a feature called Git Folders that you can use to import the files necessary to actually run the demo. Tyler just sent it in the chat. So when you open the link here, just copy the Git link here. Come back over to the Create Git Folder section, paste the link in, and then just create the Git folder. I already have one, so I'm not going to recreate it and replace kind of all the work that I have, and you should be good to go from there. Once there, you can go into the notebook itself, genai in production, and then run the first cell. And then after that, everything will start to get set up. And by the time we're done with the first half of today's workshop, where Tyler's going to run through some introductory material and some slides about genai, you will hopefully have all the resources set up to run this notebook successfully. So please be aware that it's going to spin up a vector search endpoint. That is a resource that you will have to spin down at the end of the workshop if you don't want that endpoint up and running. Okay, so with that, I will continue to monitor the chat. Please let me know. I will run through this process again for those of you who come late. So stay tuned, but without further ado, since we are at 8 past the hour, I'll pass it back over to Tyler.
Thanks, Austin. So I guess just to reiterate that, it sounds like people who already have a Databricks account, they can use the link that I just shared in the chat. So they can go in and create a Git folder in their workspace. And then they will need to have, pulling this up right now, they'll need to have a compute that is 16 point something ML. Austin will go through this again. It looks like we have a couple questions here. People asking to resend the Git link. Austin, thank you for sending that. So again, if you already have a workspace in Databricks, you just need serverless compute with 16 ML runtime, any of the 3 versions. And then you'll use the GitHub link that Austin shared to go create a folder in there. If you do not have an existing Databricks account, then you can use the Databricks Express sign up that Austin shared above, and I'll copy paste that back in. Austin, I will start going through the presentation. I think it might be helpful while I'm doing that if you're able to just kind of put this into a little bulleted list that we can share with people. I think as people are joining, they're not going to see previous messages, so we may just need to send that a couple times. Awesome. Okay, without further ado, we can move on to our workshop series, genai in production. So thank you everybody for joining today. we'll be exploring how your organization can leverage the Mosaic AI agent framework and the Mosaic AI platform to bring high quality and scalable genai apps into production on Databricks. So during the hands-on portion of this workshop, we'll show you how you can use all of the genai tools that we have to put an AI system into production. And then we'll also use our agent evaluation suite to evaluate quality, cost, and latency of an AI system. We have a Q&A chat box here, so when one of us is talking, the other one will be monitoring that. So please feel free to send questions as we go. To give you an overview of our agenda for today, workshop setup, pretend that says 10 minutes because it's now 10 after the hour. And then the first part of our presentation here is going to be, I'll be presenting some material around the Mosaic AI ecosystem in Databricks. So we'll be talking about a variety of tools that you would want to use to put an AI agent system into production in Databricks. So quick survey of those: AI functions, AI agent tools, AI playground, agent framework, evaluation, and gateway, as well as vector search. We'll be talking a little bit about what each of those are and how they're relevant to building a system that's production ready. And then from there, Austin will go into a demo where he shows in code what that actually looks like and how you would deploy, how you would develop and then deploy, evaluate, and monitor one of these systems in Databricks. And then we'll leave some time at the end for Q&A. We already went over this part. Quick intros. My name is Tyler Watson. I'm a solutions architect here at Databricks. Previously, I was a data scientist for about 5 years, so was a Databricks user and very happy to be over here helping other companies, technical teams, realize the full potential of the platform and solve a lot of interesting problems. And I work in our startups organization. Austin?
Hi, so I'm a delivery solutions architect where we get a little more hands-on with our customers and help drive use cases to production. So very relevant to this workshop. I specialize a lot in data science, and well, who doesn't want to work on AI these days? So, well, excited to show you all what Databricks has to offer.
Thanks, Austin. So let's set the stage here. Really, every organization is experimenting with GenAI because of the power it brings in productivity and efficiency of services. These numbers right here, I would guess, go up every day since this was reported. So 91% of organizations experimenting with or investing in GenAI. Vast majority of CEOs feel that companies using advanced GenAI have a competitive advantage. And then large performance increases, productivity increases that we're seeing from employees who are kind of enhancing their workflows by using GenAI tools. But there's a huge challenge here, which is it's really hard to feel comfortable putting GenAI products into production. And as you can see, the overwhelming majority of companies don't feel confident with this yet. The design patterns and development workflow and the tools necessary for it are, to a large degree, still kind of being built. So that ends up being a real challenge if you're a company interested in putting something into production that is relying on GenAI. The approach that a lot of people have tried here is using general intelligence, but AI innovation is happening at a really rapid pace. So it seems like we now see new foundation models that are setting records and benchmarks every week. If you keep up with this news, you're used to getting emails all the time about new model versions coming out that are setting new records on benchmarks. So these models are really built for general intelligence. So they're trained using a broad data set from the internet that is not connected to your enterprise data. So even the ones that have specialized skills beyond just being trained on a corpus of text from the internet, they don't know your data at your company. So this won't really work optimally for enterprise use cases. You need AI applications that understand your specific enterprise context. And this is one of the main reasons why organizations haven't deployed GenAI systems into production as quickly as they want to. So The Economist recently found 78% of organizations still have not deployed GenAI systems into production, even though everybody is working on these. And this is because they have low confidence in getting consistently high quality outputs. Could be related to hallucinations caused by models that are disconnected from enterprise data. So without the right business context, applications can do this in a way where it produces really undesirable competitive information. For example, you may have seen an example in the news not too long ago of a GM bot recommending that somebody buy a Ford car in the chatbot interface on a GM website. And then inaccurate commitments are also at risk. So another real example was an Air Canada chatbot committing to a refund based on a policy that did not exist, but the company had to honor it because their production system told a customer, yes, we'll give you a refund on this flight. So what enterprises really want and need is data intelligence, which is AI that is connected to your enterprise data. So when AI is connected to your enterprise data, you can then solve customer and domain specific use cases. Databricks provide this by offering a comprehensive set of tools and capabilities that give you full visibility into every component of your AI systems. Moving to a more specific example here, let's talk about one of our customers, FactSet. So FactSet is a Fortune 500 financial services company that delivers financial data and analytics to financial analysts. Part of their offering is a proprietary data retrieval language called FactSet Query Language, FQL. You can see it on the bottom right here. But users of FactSet don't want to learn a new proprietary language specifically to interact with FactSet if they don't have to. So FactSet wanted to find a way to take English queries and then render that in FQL, and they came to Databricks to do this. Their initial approach was to deploy a single foundation model, which was a GPT-4 model, to solve this problem. And that really didn't work well enough. Using a single foundation model that was disconnected from their enterprise data, they only got about 59% accuracy between queries and FQL, between English language queries and FQL query generation. And then you can also see they had really high latency. 15 seconds, nobody's going to wait around for that long. So the highest performing models designed for general intelligence can still give responses that are inaccurate or unsafe or exposing confidential data. And this really is not acceptable for a business to put into production. So how did FactSet address this? They came to Databricks and deployed an AI agent system. So when they did this, their performance went up considerably to about 85%, latency dropped by over 50%. And they got this to the point where they were able to deploy it into production and use it at scale. So we really differentiate between general intelligence and data intelligence, where you're using AI systems to learn, understand, and reason on your organizational data so that you can create custom AI applications and democratize access to data across your enterprise. So in this previous example, and at a lot of our other customers, we see teams realizing data intelligence through AI agent systems. So what is an AI agent system? This is going to be the focus of the remainder of this workshop today. AI agent systems move beyond deploying one extremely large model to deploying systems where a model is one component. And you have multiple components. You might have multiple LLMs, retrievers, vector databases, tools to evaluate performance, monitor, enforce security and governance policies. And all these interacting components offer a much higher quality of outputs than a single model, no matter how good that single model is, which allows organizations to deliver more accurate, safe, and governed AI applications efficiently. So our CTO and co-founder Matei recently wrote about this shift from models to AI systems in a paper published by UC Berkeley. The three components of building an AI agent system are really an agent that reasons over your data, custom evaluation specific to your use case, and then governance across all of your data, models, and tools. So that's a really diverse set of capabilities with a variety of components that have to work together seamlessly, given the complexity and the high degree of confidence that you would need to have in it before putting something like this into production. So we'll get more into this later. We offer tooling with very tight integrations for all of these components. So let's go back to the FactSet example and expand the AI agent system they built. I mentioned that a model is just one component of an AI agent system, and there are several instead of just being one monolithic AI model. So the way that they connected all these different components, the way that they architected this was by breaking this problem down into 4 components, each using an individual agent. So going from left to right here, you can see that agent 1 was retrieving the proprietary FQL formulas using Mosaic AI vector search. Then another agent applied specific query instructions using a fine-tuned open source model that they fine-tuned using Mosaic AI model training on Databricks. Another agent then generated numerical arguments using function calling, which is part of AI functions on Databricks. And then finally, an agent generated the final formula to return to the user using a commercially available LLM with no additional fine-tuning. So collectively, this is a system that ties all these agents together and has the 3 aspects we talked about. So reasoning over their data. They used a combination of open source foundation models fine-tuned on their data, retrieval augmented generation using vector search. So they augmented one of their models with their enterprise data and used function calling as well. The second part of this, from the previous slide where we talked about what defines an AI agent system, is custom evaluation for their use case. So they were able to evaluate and use multiple different foundation model providers, open source in Agent 2 and a commercial SaaS model in Agent 4, and they're still able to evaluate the overall application for accuracy of results, even though they have different components all working together like this. And then the third part of an AI agent system, governance across data models and tools. Because they were using Unity Catalog on Databricks, they had end-to-end governance from data all the way to model output, because every component of this system and all of our AI tooling is built to take advantage of Unity Catalog. So that sounds like a ton, right? And writing the code for this must be really hard. But actually, that's not the complicated part here. It's all these other components that you have to coordinate to deploy an agent system to production and then maintain it. So this graphic here shows all the different steps and processes you need to coordinate to deploy an AI agent system into production. And you can see the green part in the middle represents the agent code, which is relatively small compared to all the other things that you have to be keeping in mind in order to be willing to put this into production. So beyond writing agent code, here's just a small subset of questions organizations have to think about if they want to put AI agent systems into production. How do you prepare your data? How do you manage your compute? How do you deploy and evaluate agents? And there are hundreds of tools out there you could use for this. They all need to communicate with each other. It's a lot of different API calls. Your AI agent system takes an action and you want to know why. If you're using a lot of different tools for these components, how do you trace that back through all those to find out why it gave the response that it did? This is often really important. Being able to say, the reason it gave this answer is, explainability matters a lot. So what if you built a new tool for your agent on one platform and then you need to use several steps later when you've moved to another component of your architecture? How do you then track that tool in all your other tools and make sure it's available? And then thinking more about business risk, what if you want to make sure your agent system is following brand guidelines, not promoting your competitors, and not going over rate limits? How do you enforce that if you're working with a variety of systems that are all stitched together? And that's just a really small subset of the questions you would need to answer as you think through how to coordinate all of these when putting things into production. So wouldn't it be a lot easier if all those components were unified? At Databricks, we definitely think so, which is why we offer one unified platform that enables organizations to build, deploy, and monitor quality AI agent systems. So you'll see other providers that might have strong point solutions, or they might have some of the components of a solution available. But then customers have to integrate all those pieces together, which means a lot more time spent on ops and infrastructure and slower time to market for the actual products that you're building, the actual AI applications. So we offer the only AI solution built on the same platform as the Lakehouse, secured by Unity Catalog for robust end-to-end governance of all your data and AI assets. And that's combined with a robust way to build, deploy, and evaluate agents. We do this uniquely better than anyone else because we have unified the Lakehouse and AI in one platform. So if you're building AI on the Lakehouse, there's no need to duplicate data between systems. So you can automatically generate vector indexes, for example, and agent features from your production data. So it makes it much easier and faster to customize AI models with your data. And you're then able to build AI agent systems, fine-tune open source LLMs, train custom LLMs, classical ML models, anything you might want to do related to AI systems in production, we provide the tooling to support. We're the only provider that supports every architectural pattern for generative AI, all the way from lowest to highest complexity. So starting at lowest complexity, prompt engineering. You just want to craft specialized prompts to guide LLM behavior. Some tools we provide that would help you with that we'll be talking about more later. AI gateway, MLflow evaluation. We also support AI agent systems, which is what we're going to be focusing on today, which is where you're combining your LLM with external knowledge retrieval and access to tools. And some of our tools that you would use for this are agent framework, agent evaluation, vector search, model serving. Moving up the complexity ladder, we have fine tuning. So you're adapting a pre-trained LLM to specific data sets, and you would do that using our fine tuning feature. All the way up to pre-training, where you're training an LLM from scratch, which has historically been supported through our MCT system, and will now be supported with our AI runtime system. So you'll be able to find other tools out there that are good at one of these things, but your projects are going to evolve in complexity over time. A pattern that we see that's really common with our customers, and really what we recommend is if you have a problem that you want to solve with AI, start at the simplest end of this. Start with prompt engineering, see how far that gets you, and then, okay, that's not quite getting us what we need. Now let's move up to an AI agent system. Hopefully that thing gets you what you need. If it doesn't, perhaps you do need to fine tune a model. So we always advise starting at the lowest level of complexity and then moving up through this. And that's really a healthy development pattern that works very well and emphasizes the importance of having all the tools to support this in one place. So you don't have to deal with the transaction costs of moving between tech stacks as you realize the level of complexity necessary to build this system is changing. Okay, let's talk a little bit more about what we're going to build during this session, during Austin's demo. So today we'll be focusing on building an AI agent system, and we're going to show you how this agent can use tools to enhance its performance. We'll also show you how to use Databricks to support an evaluation-driven development workflow where evaluation data, feedback collection, and continuous monitoring are integral parts. The development workflow that we want to follow here, and that we generally want to follow when building these systems, is shown here. So we support this with our suite of production-grade AI tools. We'll be going more into detail on which tools map to what part of this. But looking at the individual steps, we start with gathering use case requirements. Then we move into a POC phase where we're building an initial prototype of the application, creating an evaluation data set. Then we measure the baseline of the solution using that evaluation set. At this stage, that might mean manually gathering human feedback on your application, could mean generating synthetic data. And then following that, you start identifying and addressing quality issues for your application, which is an iterative process. You find a quality issue, hypothesize the root cause, apply a change to improve the quality. And then once we're happy with that, move to deploying, monitoring, and continuously iterating on this. And then, as you all know, that process then just continues. All right, so AI agents sound cool, but we don't want to just use technology without specific problems for it. So what business problems can they solve? Let's talk about some of the benefits and capabilities of these systems so it becomes a bit more clear how wide the class of problems actually is that an organization can address with these systems. So really what we're using these systems for is to perform tasks that have traditionally required human intelligence. So that means working with an LLM that we're enhancing with additional information, including the ability to use tools itself. So we're giving an agency that makes it an agent. And what does this give us? It's a system with much more specialized knowledge than just an LLM, and with the reduced risk of hallucinations and the ability to go out and take action in a number of places that you're not going to be able to do just with one model. So the number of places where you might want to do this is really, really broad. Let's talk a little bit about the general structure of one of these agents. So an AI agent system has a set of tools that it can choose from, and that it can call them, it can use them to generate responses to queries. So for this example, without access to the tools listed, the one that we're showing here where the query is repeat yesterday's order, we're going to talk about some of the tools that it might have access to here. And if it didn't have these, there would really be no way to answer this question. How would it know what yesterday's order was? How would it know how to take the action of placing an order? So the first part of that, knowing what the order was, requires tabular data that's probably going to be in a SQL database. An LLM that's trained on publicly available information on the internet isn't going to have a clue what's in a SQL database at your business. And then the second part is actually taking action, which is not just generating a text response. It needs to actually repeat an order, which is something that might require a Python function or hitting an API somewhere. So the LLM needs to be able to reach out to other tools to complete this task. And then another important thing to call out here is that the logic isn't always linear here. An agent might iteratively call different tools in a preset or dynamic workflow. So look at the menu of tools, choose the ones to call, and then generate an answer from the results. So here we're saying this agent looked up what yesterday's order was, placed the same one, and then provides the text response, order placed. Here's where you can go see the details. So if you want to go implement this, what tools on Databricks would you need? We've covered the components of this system at an abstract level. Now let's talk about some of the specific products here that support these workflows and that Austin will be sharing during the demo. All right, so first, AI agent tools. These help. The agent framework in Databricks helps developers create tools, AI agent tools, that your agents can then use to perform actions beyond language generation. So what we were just talking about, retrieving structured data, executing code, retrieving unstructured data. So some other examples beyond that one would be, code interpreter tools that allow agents to execute arbitrary Python code. Structured data retrieval tools, like what we talked about in the last one. Unstructured data retrieval tools, like reaching out to a corpora of text to perform RAG that is not in a tabular format. So using Unity Catalog, you can generate functions that give you the full capabilities of Databricks, built-in security and compliance features. They're discoverable and really easily reusable, and they make it easy to do batch inference, which involves multiple tools on other platforms. You can also define agent tools in your agent code, which might be helpful for calling REST APIs or using arbitrary code that are very low latency, but those don't provide the same degree of governance and discoverability that tools that are UC governed do. Another one of our products that you will probably want to use is AI Playground. So now that you have some tools that are defined as functions, you probably want to get a better idea of what it actually looks like when an agent is interacting with them. So we give you a UI to do this called AI Playground, which is a chat-like environment where you can test, prompt, and compare LLMs, including prototyping LLMs that use the AI agent tools you created. There are also AI agent tools that come out of the box with Unity Catalog. You can also interact with those. So after you've prototyped and refined an AI agent in AI Playground, you can click one button to get the Python notebooks with all of that agent code in them, which is extremely valuable. If any of you have worked with AutoML before, you know how useful it is to get 75% of the way to a production level solution done, provided to you as a notebook, and then you can go augment them for further development. It really speeds up the process. Or if you interact with a model in AI Playground and, hey, this is already offering the performance that you want for your production system, you can deploy those models directly as model serving endpoints and then start hitting them. So putting these options together in a simple UI really reduces the operations cost involved in prototyping these systems. It makes the development workflow that we were just talking about much smoother in Databricks than you'll find elsewhere. All right. The next two tools that we're talking about are Agent Framework and Agent Evaluation, which are both suites of tools that cover different parts of the AI systems in production flow. So these are meant to be used together iteratively as part of your workflow. So when you first deploy your proof of concept and start collecting feedback, you'll want to log interactions with your agent and then collect feedback on them using the review system. These are both part of the agent framework. Then you'll use agent evaluation to continuously compare agent responses and the associated metadata with that evaluation set. So this will use components like LLM as a judge to generate quality assessments along with latency and cost metrics, which is part of our agent evaluation system. And then when you're ready to deploy and monitor your agent, you'll be using the agent framework again. So there's a one-line deploy step, and it will generate agent-enhanced inference tables and continually update a monitoring dashboard. AI agent framework and evaluation cover a large number of tools. So let's talk some more about those. Doing AI development outside of Databricks means using a lot of different tools for every component of this loop here. So we want to simplify this by providing a set of tools for developing agents in agent framework, as well as a set of tools for both automated and human evaluation of agents in agent with agent evaluation. So agent framework, that's our set of tools supporting the full development lifecycle for AI agent systems. Some things that it provides would be MLflow chain logging, parameterized agents that define agent behavior based on config files. So that makes it really easy for you to iterate through those during development. And then agent serving, which lets you do streaming serving, credential management. And then we can also talk about the agent evaluation enhancements that we provide there for the evaluation portion of this. So MLflow tracing for debugging and optimizing RAG in agent internals. We provide a review app for collecting stakeholder feedback and building a golden labeled data set. And then the LLM as a judge system and associated metrics for retrieval, generation, and system tables are very, very useful here. So the agent framework and agent evaluation suites are usable separately, but all of these tools work together and leverage the governance and lineage capabilities provided by Unity Catalog. So a lot of our customers say that I would say almost all of our customers really say that monitoring and evaluating the outputs of their AI agent systems is critically important for having confidence in their performance, which is why we've invested so heavily in building tools that make it very easy to do that. Okay, another tool that I want to discuss here, since we will be using RAG in a part of the demo, is Mosaic AI Vector Search. So this is a vector database built into Databricks and integrated with Unity Catalog. This is useful not just for RAG, but for any system that needs to quantify similarity across embedding representations of data. So recommender systems and image and video recognition models would be another example. With vector search, all you need to start is a source table. You can either bring your own embeddings or you can start with non-embedded data and choose an embedding model. We then create a vector index for you, and then you can call the endpoint for real-time retrieval of vectors. You can set your indices to sync on a certain schedule or to continuously sync anytime there's a change in the source table. We provide a lot of flexibility there. And the beauty of vector search is that if you're doing this in Databricks and your data is already in the lakehouse, you're not duplicating anything. This is just running on top of tables that you already have there on whatever schedule you need. So there's no new API calls, no new infrastructure. A couple other tools that are going to be relevant here are Mosaic model serving and AI gateway. So model serving is our solution for deploying AI models for real-time and batch inference. So every model you serve is available as a REST API. You can integrate that into your web or client application. And then since it uses serverless compute, it provides a highly available and low latency service for deploying models. The service will automatically scale up or down to meet demand changes, which saves you infrastructure costs, and it also optimizes latency performance. We support serving foundation models in Databricks, whether they are served by Databricks, trained in Databricks, or completely externally hosted. And then you can also serve agents and custom Python models packaged in MLflow this way. And then AI Gateway further streamlines the usage and management of genai models by bringing governance, monitoring, and production readiness to the endpoints that you're creating with model serving. So one of the best things about using AI Gateway to manage your model serving endpoints is that you can seamlessly create inference tables, which simplify monitoring and diagnostics for models by continuously logging serving request inputs and responses, meaning predictions, and saving them into a Delta table in Unity catalog. So you can then use all the capabilities of the Databricks platform, like Databricks SQL queries, notebooks, to monitor, debug, and optimize models, where all of this is just getting logged in Delta tables. So once more, using that full suite of Databricks tools for AI agent systems helps you fully leverage the power of the data that you are already generating. Some other really cool benefits that come from using AI Gateway to manage your model serving endpoints is you get permission and rate limiting, so you can control who has access to your endpoints and then how much access, which is provided through Unity Catalog. You also have payload logging, so you can monitor and audit all the data that's coming to your APIs. With usage tracking, you can monitor the operational usage and their associated costs using system tables through Unity Catalog. And then we also provide AI guardrails, so you can prevent unwanted data or unsafe data in requests and responses through natural language here. So this is how you would prevent violations of brand guidelines, tell your model only respond to questions in this topic area, avoid using these words, focus on these things. And then you also have the ability to route traffic to different endpoints here. So this does not represent all of our AI products in Databricks. We've covered all the features that are important for essential for putting AI agent systems into production, but all of these sit within the broader Databricks platform. So a few key points is that many of the capabilities that you need to put GenAI systems into productions are also general Databricks Lakehouse capabilities. So do you need to monitor an AI pipeline? That's a data monitoring problem, which Lakehouse monitoring can do for you. Do you need to manage permissions on ML models? Really easy to do if your data is governed by Unity Catalog. So this data-centric platform just makes it easier overall to take GenAI from development to production, which is a huge step. So you can get started quickly by using familiar tools in our notebooks, in your favorite IDE, third-party tools which integrate, and our runtimes and clusters will give you ready-to-go environments for this with LLM libraries like LangChain, the OpenAI SDK, transformers, and then CPU and GPU clusters, which can scale up or out. To move to production, as we've been discussing, we provide a really smooth path for moving code, data, and models to deployment. So if you already have your data in your Lakehouse platform, why not use all of it for AI? It's going to give you some very large enhancements on anything that's generally available, and you already have it. Why not make the most of it? That then sets us up for Austin, who's going to go into a demo where we'll be reviewing all of this in a more hands-on way. Austin, I will turn it over to you and switch to monitoring the chat.
Thank you, Tyler. Thank you for the presentation. So for some of you, that was probably a lot. Like there's a lot of different features, and if you're new to Databricks, oh my God, there was so much to go through. Ultimately, the point of this demo and the workshop itself is to kind of highlight how you would use some of these features and how it would look in production. But if you wanted to get into the details of actually creating some of these applications or even understanding how to do something like a RAG chatbot on Databricks, I highly recommend checking out our training catalog, which has much more specific, detailed walkthroughs for each of these specific topics. But hopefully after today's workshop and demo, you get an overview of what is possible on Databricks and then kind of branch out from there. I know there's quite a variety of levels of experience on this workshop right now. So this training catalog could be a great start for some of you who are brand new to generative AI. So with that, let me share my screen again. And this is the page I wanted to show you all, where you'll see some of the courses that you can take self-paced. Okay, so to recap what you need to get set up, I'm going to copy and paste one of my messages here. You do need a workspace. So I did a little digging while Tyler was presenting his slides. There's a possibility that the serverless workspaces may not work for this workshop, but that's because it's running on Databricks serverless, and there may be some features that are not there that are on like the traditional Databricks workspace. So keep that in mind, it may not work there, but at the very least, if you are able to spin up a cluster, if you have the permission/policy to do so, try to spin up a cluster with at least Databricks runtime 16.0 or higher. I'm going to navigate over to our compute section once more, create compute, make sure machine learning is checked, at least 16.0 or higher, so one of these three, and the rest you can just hit create. As long as we have machine learning and then a 16.0 or higher runtime, it should work. And then finally, when you want the code itself, go to workspace. Yeah, I don't need that one because I already have one. And then you use Git folder over here on the top right, hit create Git folder, and put the Git link of that repo into this space to actually bring the files in. Okay, so that's getting the workspace set up for this workshop. I'm going to jump over to the notebook itself, which will have the following files here: data, rag setup, config, and genai in production. Genai in production is the primary notebook that we're going to use for this workshop. But as a step 0, we want to go into configurations and update any of these variables to what you have in your workspace. This is kind of by default set to what my naming convention was. But if you want to change what catalog you're using, what schema you're using, et cetera, please change it here. I'm sure there's some of you with some policies that require you to do certain things in certain catalogs and so on and so forth. But if not, I feel free to leave it like this. I guess you'll have my name on your catalogs and so forth. You can also change what model is being used, and what embedding endpoint that you want to use here, and so on and so forth. So with that, you realize this is my typo here. Do not need that. Okay. So when you get started with this, you're going to run these first 2 cells, which is run config and then run rag setup. I'll actually rerun this. These 2 cells may take you a significant amount of time because it's spinning up a vector search endpoint, which is a critical piece to actually enabling RAG. You saw in Tyler's slides that there was that vector search slide that's essentially enabling the vector retrieval, vector database retrieval. And it will be a critical component because what we're going to show in the notebook itself is how we take a functioning RAG code and then doing evaluations on it. So we do need that piece so that you can see how that evaluation happens. Okay, so I'll take a pause there. Ultimately, everything I just explained right now is actually just setting you up to see how your GenAI application would look like in production. So, and in order to show that, we have to give you sample data. We have to give you a sample working bot and so on and so forth. So a lot of what gets downloaded, especially in this config cell, is sample data, is sample code that will be used to demonstrate some of these capabilities. So bear that in mind. You could go in and dig through some of these configuration and setup folders, but again, not necessary. And if you do want to get into the details of that, please check out the training catalogs so that you can see a much better, deeper dive into set code. Okay, so with that, I'll let this run a bit because the next few cells are actually not too difficult. We're going to start in the same kind of agenda that Tyler had, where we started with AI functions. So some of you who are following along for this notebook, you'll probably be stuck in these two cells for a little bit of time. This is going to take quite some time, and due to the time limit of this workshop, I'm going to have to keep going. So it may finish running by the time we're done with the workshop, but it's setting up a number of different resources in order to enable the workshop. So what's going to happen first is that we're going to show you how to use AI functions on Databricks. Fundamentally, this is your out of the box solution that you can use right away on Databricks. Don't even need to think about like what's really how to set up the AI model itself in order to accomplish specific tasks. So you can see we have a number of different AI functions. They're pretty self-explanatory in terms of what they actually do, right? AI classify, AI fix grammar. That's pretty straightforward. But ultimately, we designed this for perhaps like the data engineer who doesn't really want to get into the weeds of how the LLM itself works, and they just need something that works. And so we have these functioning as SQL functions, which you can use alongside your existing SQL queries, or you can make new SQL queries to augment/supplement your existing ETL pipelines. So it's essentially just adding it as a function that many data engineers are very familiar with. And you don't have to learn data science. You don't have to learn machine learning. You don't even need to know how the large language model itself works. You just know that based on how to use this function, this is how I can achieve my task. And so again, AI fixed grammar, very straightforward. This sentence, which one did I say? This sentence have some mistake. If you think this is clearly incorrect in terms of English grammar, and it corrects it. AI similarity is trying to see how similar two words are. So Databricks and Apache Spark, not similar at all. But if it was Apache Spark and the Apache Spark engine, the score is a bit higher. So very simple examples that you can see here. I'm not going to go through every single one because, again, it is pretty straightforward on what these AI functions do. But if you need additional control, and you need a little more customization in what these functions are doing, we try to drive customers towards using AI query. And that's because AI query actually allows you to insert custom prompts or different prompts to help you manipulate your data with the large language model in batches. And we also call this batch inference as well. So if you're familiar with prompt engineering, this is kind of where you can shine as well, because depending on how good your prompts are, you can also create a pretty good output by using AI query. In this particular example, we're looking at a row of about 1,000 misspelled cars, and just asking it, hey, you're going to receive a make of a car. Can you check to see if it's misspelled and real, and try to correct the mistake? I can specify the model itself here and let this run. So it'll go row by row and actually try and correct the misspelled make. Very simple example. It's as straightforward as it gets for a large language model, but it does highlight how you can use AI query to not only customize the prompt for a task that may not be suitable for the other, default out of the box functions that are very, exactly what they're going to do, and they do that task really well. You can add additional prompts, instructions to make AI query something of your own. Okay, so I will warn you that this will run against 1,000 rows of different cars, which means it's going to hit this endpoint 1,000 times. So if you don't want that to happen, please come down here and actually write like limit 1, limit 3, limit 1,000, etc. Just to limit how many rows this actually hits for the purpose of maybe you yourself seeing it, or you want to avoid hitting the API too much. Down below, because this is a simple task, there is another example of using the 8 billion model, which is significantly cheaper than using the 70 billion model. And that's primarily because, well, the parameter size is significantly lower. So if you have a task that's not too complicated, like a spell check like this, we do recommend you actually try to use a smaller model because of lower costs and better latency. So all the details on what powers these AI functions and are on our documentation. There should be a link in the notebook as well, telling you what exact models is powering these AI functions and how you can use them, what parameters you're looking for, and so forth. But AI query, you can see you have a bit more customization. So you just need to specify which model you're using and what the prompt itself is, as well as the data itself that you're going to use for AI query itself. So that's AI functions. Very easy to use. You can use this in our SQL editor as well. Frankly, it may not even look that different to a data engineer who's been using SQL for a very long time. It might just come as second nature at this point. Okay, so that was kind of like the beginning of your, let's say, your Gen AI journey, right? That was very simple. We have tools out of the box on Databricks that work, right? And you don't have to worry about scale. You can use AI query for that. You don't have to worry about managing the model. You don't have to worry about hallucinations and things like that. That's something that we are handling with AI functions. But everyone has a different use case. Every use case varies in complexity. And so we need to have different ways in order to augment, supplement, or help improve the large language model or your different Gen AI models to be production ready. And that's where function calling, tool calling, whatever you'd like to call it, comes into play. And we use the Mosaic AI tools on Unity Catalog in order to accomplish this. One, for those of you who are not familiar with function calling or tool calling, one of the biggest problems of large language models is that they do hallucinate. And that's primarily because there's only so much training you can do on a large language model. We're not going to go into the details of where the hallucination itself is coming from. But ultimately, we can use tools to get live data. It's like the stock market, weather, and so on and so forth. And so on and so forth. All right, we'll capture that later, and so on and so forth. And then help the large language model be a little more accurate or much more accurate, depending on who you ask, in the output itself. So live stock market information isn't going to be something that the large language model can accurately answer. So to kind of demonstrate this, I have an example here where you can ask it about this Pokemon called Sinistcha. And when you ask it, ask perhaps which one did I use here, Llama 3.3. This model is not trained on the latest Pokemon. And because of that, it will hallucinate something and give you a completely incorrect answer. By implementing tool calling, which I'm just going to define using Python code, which is going to hit an external Pokemon API database, we can have the model recognize it needs to call a tool to get more relevant information so that it can answer the question more accurately. I'm going to skip over all this code because it's just setting up the tool itself to call the Python function we defined earlier. And so we have here, tell me about Sinistcha one more time. We're going to run that conversation, and we're printing out some of the outputs of the model itself, where first it reasons what tool to call, and then it gets the information from the Python code, and then sends it to the large language model to give us a more accurate answer, which we see here is grass, ghost type, Pokemon, et cetera, et cetera. This is accurate. And this is an answer that I can trust because you can kind of see here the information that it got from that API call to the Pokemon database. if you're confused as to how all this happened, rest assured, we do have the training catalog for you to dive into um, to understand how this is working. And you can also take a look at online the different articles that have come out about tool calling / function calling, as well as the whole React framework, just to understand how the large language model is able to reason and then take action on the query itself. But you can see that through the use of tool calling, we're kind of not only accomplishing retrieval augmented generation, but we're also improving that accuracy. So if you've been using services like Perplexity or I suppose Search GPT and so forth, they're essentially using function calling as well, right? Because they're looking for the latest information to make their answers more accurate. And it's a really critical part in making sure your application is production ready because you want accurate information. You want to look at your data. You want to retrieve your data that is true and have the large language model look through that and then create the answer. You don't want the large language model to just kind of create something, right, based off nothing. You want to get the right information and then have the large language model create the right information. So that's the idea around function calling, tool calling, a very important piece in order to make sure not only your genai applications are production ready, but also ready to have access to your data as well to give more accurate answers. Now, what you did see though was that I had written that tool or that Python function just from scratch. It's going to be there in memory. How could I scale that tool, that Pokemon lookup Python function, so that I can use it with almost all my GenAI applications? Or how could I avoid maintaining some of the maybe security credentials or the various different accessibility needs of said code? That's where the Unity Catalog tool calling functionality comes into play. Thanks to Unity Catalog, we have that unified governance that allows different people, different notebooks, different assets on Databricks to access that tool itself, and it manages all the credential management, all the security, and so forth for you. So you only need to write it once, and you're done. Again, I'm not going to go into like what exactly Unity Catalog is, of course. So if you will need kind of like a review on our pitch on Unity Catalog, by all means, take a look at how Unity Catalog works. But Unity Catalog tool calling is essentially taking a UDF or another SQL function, creating that using SQL essentially. You can create this tool using SQL, or you can put in Python code as well, and use frameworks like LangChain and other Python code to actually call it. And you only need to define it once, and you can use it across your workspace. And just to show you where they live, I'm going to jump over to the catalog itself. Do apologize to anyone here who is new to Databricks and don't quite understand what I mean by Unity Catalog and catalog schema and so forth. But I hope you can kind of see where I'm headed with this. But when we jump over to my demo catalog, I have a schema here called agents. And you can see here there's tables, volumes, models, and functions. There's 3 functions here that I created from that notebook and that you will create as well in this notebook. And batch inference, playground query test, hello there. So if you're, again, familiar with Unity Catalog, you know that given the right permissions, pretty much any model, any GenAI model that you have, or anyone with a notebook can access these functions pretty much anywhere. Again, given the permissions, of course. It's not like anyone from anywhere can access it. I'm sure there will be proper security permissions set up across your workspaces. But again, I don't have to recreate these functions over and over and over again every time a job runs or every time I need the model to access a specific tool, it's here, it's stored in the Unity catalog, and you can use it right away. And when you come over to the playground, which Tyler talked about in his slides, you can try and tinker with some of the new tools that you have in this little drop down right here. So you can add the tool by actually selecting your catalog schema and then the specific function that you have created. You can use star to actually use all of them. So you can add that and then actually test the tool itself. So again, if this was all kind of flew over your head, no worries. There's a lot of kind of context that you do need to understand about Databricks to understand where this can kind of all plays. But here in the playground, this isn't code that I had written or anything like that. This is not, I'm not rerunning the notebook that contained the function itself here. I have it already saved in Unity catalog, and now any model endpoint with the right permissions can access that tool. And so you can see that happening here. So I'm using the Llama 3.3 70 billion instruct model serving endpoints, which is down here. And it's able to use the function or tool that I had defined on Unity catalog. Now, if you want to see this happen in code, you can use LangChain and their agent framework to actually pass the list of tools to a model, and it will do the exact same thing that you saw earlier, where it was trying to call a specific tool. It's a lot here, but essentially what I did here was took the AI query code that you saw earlier and ran another batch inference job just to show how it knows to call this specific function, because I actually specifically said, if I say start batch inference, you need to use this tool. Okay, so with that, why is this all important with Unity catalog? Ultimately, at the end of the day, when you start to chain these agents together, they're all gonna be hitting different tools. They're all gonna need to process the data throughout that job, that pipeline. And at a certain point, you may want to hit various different models and different tools in order to accomplish your goals. So in this case here, you can actually see that for the LangChain tool calling portion of this, I'm using the Databricks Llama 3.3 70 billion model. But when I actually use the AI query function that I had defined earlier, I'm actually using the Llama 3.1 8 billion instruct model here, because like I said earlier, the task that this is doing is really simple. Like all of you can probably prompt engineer a spell check essentially, right? I don't need a 70 billion model to do a very simple task. So I specifically said use the 8 billion model in this function. So no matter where I call this in Databricks, it will always use this endpoint or this model, which is the 8 billion model. So I'm using multiple models in conjunction with each other for a more optimized GenAI application. Trying to do this batch inference with a 70 billion model is way too expensive and frankly overkill. But that depends, right? It does depend on the use case that you're working on. And if you do require the power and accuracy of a 70 billion model, then yeah, by all means, put that in your tool, put that in as part of your step-by-step process. But you can start to see how there's different building blocks that is enabled thanks to Unity catalog and Databricks tying that all together. So sorry that it's a little hard to visualize here, but once again, the LangChain portion of the code is using the 70 billion model, while the batch inference portion is using the 8 billion model. If you're curious on how the model management is happening itself, you can go over to serving here on the bottom left, and it's used, and that's where all the models are stored. So if you do upload your own model from like Hugging Face, for example, maybe there's that fancy new model that came out, DeepSeek, Glen, any other open source model, you're more than welcome to upload it there and actually use it as an endpoint here as well. So the combinations are frankly endless. Okay, so this title, RAG in production, is not going to walk you through actually creating the RAG chatbot. We have a training catalog for that specifically, so please check that out if you want to see how to use our review app, how it's going to collect feedback, and how you actually use MLflow to create the entire chatbot itself. So go to the training catalog to actually see that happen. But what we're going to do here is actually just recreate that in the back, which is what the next cell is going to be here, and then show you how to actually evaluate that bot's quality using the Mosaic AI agent evaluation framework. Now, the way this framework works is that it uses LLM as a judge and synthetic data evaluations to evaluate how accurate, how trustworthy, how grounded / how much hallucinations is happening with your application. It's not only for RAG, but it's mainly used for RAG because you need to make sure not only the application itself is, working as intended, but also the retrieved chunks, right? Like, am I even getting the correct chunks, the correct information for the RAG chatbot to actually work well? It might not even be a problem with the large language model. It just might be the way the embeddings were. It may even be just a matter of how you chunked the information. There is a great article that came out a couple of days ago from one of our subject matter experts who demonstrate significant performance improvements from fine-tuning the embedding model. I won't go into details on the differences between the embedding model and the large language model, but you can see that there's options, right? Maybe it's not the large language model. Maybe it's the embedding model that you're using. It could be a lot of things, but how do you know that without evaluating what your application itself? So when you run this cell, you're going to actually run through some LangChain code that's going to use MLflow LangChain, the MLflow LangChain flavor to actually log the model and create new versions of the model so that you have different versions that you can always fall back to. So when you run this, you'll have that code, and then run this cell down here. And let me see here. Let me run that just so you can see what appears. Great, and then I'll run this. So what's going to happen here is that we're going to use MLflow to actually register that LangChain code into the MLflow experiments page right here. You can also take a look at it on the right side here. If you need a deeper dive into what MLflow is, we have a great end-to-end AI / ML workshop as well that you can take to see how the whole MLOps / MLflow works on Databricks. So what just happened was that I just ran this just so that you can see the version actually get updated. So it created version 12 of my model here and is located at Austin Choi demo catalog, RAG demo. So if we actually navigate back over there to my demo catalog, RAG demo, and then we go to models, it's this model right here, right? So I think there was a question in the chat about like actually versioning your application itself, your genai application. If I click into this, you can see I have many, many different versions of this bot. Half because I've been rerunning the code a lot, but also because I've been making tweaks into the RAG bot itself. So I'm testing different ways of how I can improve the RAG bots in performance. And if at any point I don't like it, I can always revert back to a different version. But ultimately, we're using MLflow to do that versioning and determine, hey, which version is good? How well did that do compared to the last one? And if this is starting to sound a lot like MLOps, you're thinking in the right direction. There is one more thing that does appear, and this is thanks to the great work of our engineers. You can notice that you'll notice that there's one line here that says the log model is compatible with the Mosaic AI agent framework. What does that mean? We recently came out with a feature called the synthetic data evaluation. If you don't have enough of your own data to actually evaluate your RAG application, we generate some code for you that you can copy and paste into the next cell and actually generate some synthetic data to do that evaluation. Now, if some of you are like, oh my God, that's kind of crazy that you're going to use synthetic data that's generated from another large language model to do that evaluation, I understand where you're coming from, but it's also where a lot of the recent reinforcement learning innovations have come from, and is a great workaround if you really don't have that kind of data. So it's better than nothing is what I'm also trying to say with this. But you're always welcome to use your own data set, and we've generated some code here to help you do that evaluation. But I'm going to demonstrate the synthetic data code here. You can just copy and paste this over. There is a table set up with some example Databricks documentation that you can use in conjunction with this to do that evaluation. So I've already pre-pasted, I suppose, that code here for you to actually run that evaluation. So all you need to do would be hit run on this, and then it will run through a number of different LLM as it judges to actually evaluate the RAG chatbot that you had created. So I've only asked it to do 10. So it'll run through 10 different evaluations for that RAG bot. And then we could take a look in the UI to see how well it did. So let's give this another second. And with that, so this part actually creates the evaluation data set itself, and then uses that to actually do the judging itself. If you want to see this with an existing data set, you can run the next couple cells down here to do exactly that. So I'm not going to run that just yet, essentially because this is our newest feature, and the other one is essentially we're using MLflow evaluate and LLM as a judges to use your existing data to do that evaluation. So kind of as expected, I've noticed that the way that this RAG chatbot is prompted is not great, but that's kind of the point of the demo, to show you like there's very obvious right and wrong answers to this. What I just did was click this button that appears after the evaluation is complete. It'll open a new tab and it'll actually take you to the MLflow experiment where that evaluation actually happened. And now you have a full UI dashboard, essentially, or a UI view into what went well and what didn't go well. So let's look at one that failed, right? We can click into this particular question and see what the assessment says. Like, okay, why did you think this was not good? Why did you think this was bad? And we can see very detailed analysis from that LLM as a judge, which gives us a really good idea of where patterns are appearing and why the particular application is not doing well. So instead of you manually going through potentially thousands and thousands of different rows of results just to see potentially if it's performing up to your standards, this is a great way to accelerate that and remove a lot of that manual work. So this is one that failed. You can see the input, like the question that was asked and what the model responded with. And these are the expectations that we kind of expect in the answer itself. And you can do a deeper dive into like the actual chunks that were retrieved here. And there's a link to what it was here. But let's look at one that actually succeeded. And you can see that, it was correct. And you want to see why it was correct. You can see that here as well. And you can see what the inputs and outputs are down here. So incredibly valuable, especially when you have a working RAG chatbot, but you don't really know how to review, understand how good that RAG chatbot is. All right, so moving back, that kind of is your final step in creating that RAG chatbot, right? Of course, you're going to gather feedback. Of course, you're going to need to monitor your RAG chatbot and make sure traffic is not being abused for that RAG chatbot and so on and so forth. But most importantly, you need to make sure that it's production ready. And that's where this evaluation tool comes into play in order to make sure that the chatbot's ready to go. Okay, so when it is, we have a lot of different tools post-production that you just kind of saw all near the end of Tyler's presentation that help in operationalizing and maintaining your RAG chatbot or any other genai application after release. So one thing I'll point out alongside this is the Mosaic composer training for fine-tuning large language models, particularly because I can show you how AI query would work in this case, including fine-tuned large language models. So what I'll do now is actually navigate over to model serving here and go over to our fine-tuned model. So this is our fine-tuned. This is a model that we've actually fine-tuned using the Mosaic Composer training service, but I'm not here to go into detail about that. I'm here to go into detail about Gateway, AI Gateway specifically. So this is where Tyler was mentioning that this is where you can limit the traffic, you can put in guardrails, you can put in inference tables to monitor and track the model itself, which is really important because you don't want someone spamming your endpoints. You don't want people to abuse it. Even internally, there may be people who are just asking the wrong things, right? Completely off-topic information that really isn't relevant to the chatbot itself. So that's where AI Gateway comes into play. You can enable usage tracking, which will gather metrics on how well this endpoint is doing. Inference table takes all the inputs and outputs that are generated from the model itself and saves it to a Delta table. AI guardrails, you have a plethora of options here to actually upload valid and invalid keywords/topics, as well as detect for any PII. A lot of things that you may have to set up on your own because that's just good post-production operationalization, right? But we give you that kind of out-of-the-box solution here with AI Gateway. You wouldn't need to set up your own custom solution here. You can use AI guardrails here to actually watch for PII. Like I definitely don't watch your social security number, but make sure PII detection is enabled then. And of course, rate limits. We don't want your bill to go sky high. We don't want any endpoints that you deploy to be DDoSed or attacked. So rate limits can help with that as well. Another thing that helps with rate limits is throttling traffic to any API providers that AI service providers that you are using, like Anthropic, OpenAI, Together.ai, and so on and so forth. We do allow you to actually create endpoints. I'm going to actually navigate over there, create serving endpoints. So it will essentially function like a model serving endpoint. So when you use create serving endpoint here on the top right, you can actually select a foundation model that's from Anthropic or OpenAI or Bedrock. We don't limit you to using Databricks hosted models. You are welcome to bring your models in. We just want to help you productionalize it. And so, you put your API keys in here and set it all up. I'm not going to do that in front of all of you, but you still get the option to use AI Gateway to help you monitor that traffic, to help put up those guardrails, to limit how many messages are sent to that API key, because you probably have limits on that, or you probably don't want to exhaust the limitations that Anthropic has put on you or OpenAI has put on you, because they also throttle their own API requests because they don't have unlimited GPUs to be running these models. So that really is where we that is really where we want you to succeed, is in production. How can we make sure everything is in production safely and gives you the ability to monitor all your applications? So with that, I will wrap it up, which kind of showcasing the power of a fine-tuned model. I'm not going to run this because it actually scaled back to 0. But what we did here was we took a 1 billion large language model and actually fine-tuned it on some medical terms to medical extraction much more effectively. And you can see here that we have a 70 billion model, a 1 billion model, and a fine-tuned 1 billion model. And you can see that the baseline Llama 1 billion model doesn't perform great, but the fine-tuned one performs accurately, just as accurately as the 70 billion model. So I've tested it on the playground. I'm satisfied. I'm like, okay, you know what? This fine-tuned model is working pretty well. So let me deploy it and make sure I have all the necessary protections and guardrails set up so that I can use this in production. So you can come back over to the serving endpoints. Since we already have one, I'll just show you how we have it set up. We would create a new serving endpoint. We would take the fine-tuned large language model and set up the necessary configurations, which in the purpose of this demo, we didn't really configure anything, but you would configure it here. And now we can use this endpoint in our workloads. Okay, so I know it was a lot. I saw there was a lot of messages that came in through the Zoom chats, and we definitely lost a few people, but that is essentially genai in production. You have the repo to these notebooks, and if you have any other questions or if there's any other concerns, you're always welcome to reach out to me and Tyler. But with that, I'm going to stop sharing and see if anyone has any more questions. Again, apologies if this is your first time at Databricks or first time using Databricks. It is a lot to get through, but I'm hoping the training catalogs that we sent over in the Zoom chat will help you get a better understanding and maybe even give you a better starting point than what you saw today. All right. Well, we are happy to stay on for a bit longer if anyone has any more questions. But Tyler, any last words from you?
No, I see that we have one question here that that I think we can address from Alice, which is from the evaluation-driven development workflow PowerPoint page, there's a step called measure baseline. And Alice is wondering how the system that we were showing measures the baseline. And I believe that would be during the evaluation step would be the equivalent of that in the map that we showed in the review app.
Right. This is, I think, will be good feedback for a future workshop, but there is a step that we skip here where there is a review app that's generated, and that is where we kind of collect feedback from real users, right? You can definitely see that in I think one of the training catalog courses actually offer this for a RAG chatbot, but like they show you how the review app is created, right? And then we collect the feedback, and then we can use that against the LLM as a judge, or even create a custom LLM as a judge. So that essentially would be where the baseline is created. But I do apologize for not being able to show that given our time constraints. But that is a step that we would do before actually having a full RAG chatbot.
Yeah, Alice, hopefully that answered your question. Thanks, Austin.
Also, Daniel is asking how much execute something model. I think feel free to chat directly with us, Daniel, if you mean cost. I think it's the total cost of actually executing. If you're talking about LLM as a judge, it does depend on how many evaluations you do and the size of the chunks that need to be retrieved. If you're talking about batch inference against each model, that will also depend on what model you use. Obviously, the smaller ones are smaller, and then it also depends on how many rows you're feeding it, right? So if like that one row had like 20 columns, that's kind of a lot of information. And it also depends on each cell, like how much information you have in each one. And how what's the number of examples needed for the 1 billion LLM fine tuning? The minimum number of examples, we actually are starting to see this in terms of like tokens. So 5 million, 10 million tokens is ideal in order to get it specialized to your specific tasks and running it through about 10 epochs. Granted, there is a lot of research now that shows reinforcement learning can do things and using that and creating a distilled model is a lot better. But we've seen using that amount of tokens and that many epochs to really hone in, per se. I don't know the correct word for it, but it helps specialize these smaller models more effectively, especially since they can be influenced a lot more than the large language models. And sorry for anyone who's still here. There was a chat directly to me and Tyler, and where we're asking the minimum number of examples needed for a 1 billion LLM fine tuning. So another good thing too is that fine tuning the 1 billion model is very cheap. What you saw, the fine tuned model that I very briefly showed, only costs $10, but we also only used a few thousand rows of data. So feel free to experiment. It's not very that expensive. Yes, another question for everyone still here. Are you planning to integrate new reinforcement learning based trainers in the near future? I know the Mosaic team is considering it, but not in the near future, I'd say. Yes, the recording will be shared. Yes, you may have seen another one of our co-hosts, Kristen. She will be sending out this recording.
Yeah, I think everybody should get it in about 24 hours.
All right. Okay, well, with that, again, thank you for hanging on with us. There's a lot of stuff for us to get through, and I know that there were some hiccups with some of the workspaces, but it looks like a lot of it was taken care of. But otherwise, thank you for joining. If you want to see this again, we have another session next month. But again, please check out the training catalogs as well. Thank you all, and we'll see you. Oh, feel free to reach out to us, of course, if you need any help with this. So see you on Databricks, I hope. Take care all.
Thanks, everybody.